Hello friends, I hope you're doing well. Welcome to the third practice set of the geometry series. Let's get started here. So we have a circle with center -1, 1, and there is a point on the circle 4, -3, and there is a tangent line T going through this point 4, -3, right? And we have to find the x-intercept of this tangent line. So we have to find the coordinates of point P where this tangent line cuts the x-axis, right? The center is not the origin, the center is -1, 1, correct? So obviously we should think about how can we write the equation of this line T or the tangent T, right? We know the coordinates of the center and the coordinates of this point, right? So this will be the radius, right? So this will be the radius, and we know that the radius of a circle is perpendicular to the tangent, or the tangent is perpendicular to the radius. So from these 2 points we can find the slope of the radius. Once we have found the slope of the radius, we can find the slope of the tangent, because the slope of the tangent would be the negative reciprocal of that of radius, and hence we can try to find the equation of this line T and then find the x-intercept, right? So let's go about it. So the slope of the radius would be will be 1 minus -3 divided by -1 minus 4. So this comes out to be 4 over -5, or -4 over 5, right? So that's the slope of the radius, right? Let's say this point is R. Okay, so the slope of the tangent would be the negative reciprocal of this. So the slope of the tangent would be 5 over 4, right? The negative reciprocal of this slope. Hence the equation of our line would be y is equal to 5 over 4x plus b, right? We know that the equation of a line is in this form, right? Y equal to mx plus b, where m is the slope and b is the y-intercept. Now this is the equation of our tangent, but we don't know the value of b, but we know that this tangent goes through this point, so we can plug in this point here to get the value of b, right? So let's do that. So -3 is equal to 5 over 4 times 4 plus b, which gives us b is equal to -8, right? Hence the equation of our line would become y is equal to 5 over 4x minus 8. So this is the equation of our tangent line. Now to find the x coordinate, the value of y is 0 here. So let's plug in the value of y 0 here. So 0 is equal to 5 over 4x minus 8, or in other words 5 over 4x is equal to 8, or x is equal to 32 over 5, or 6.4, right? So the coordinates of this point would be 32 over 5, 0, right? Again, just to quickly reiterate, we found the slope of the radius, hence we found the slope of this tangent line. We have a point on the tangent line, we used that to find the value of b, essentially the overall equation of this line, and then find the x-intercept. Question 2. We have a cone, right? And on the top of the cone we have a hemisphere. The total height of this whole thing is 9 centimeters from the very top to the bottom, and the diameter of the hemisphere is 6 centimeters. Okay, and we have to find the total volume of the cone. So we have to find the total volume of this cone. Now obviously it's a combination of a cone as such and the hemisphere, right? So let's find the volume of the cone and also find the volume of the hemisphere and add them together, right? Now the volume of the cone is given by 1 over 3 pi r square h, right? Where r is the radius of the cone of the base of the cone or the top of the cone in this case, and h is this height, not the overall height, because we're talking about the cone. So this is h. Okay. The volume of the hemisphere would be half times the volume of the sphere, and the volume of the sphere is 4 over 3 pi r cube, correct? So half of this, because this is a hemisphere, right? Okay. Now, if we look at the hemisphere portion, the radius of the hemisphere is clearly 3. So r is clearly 3 here, right? Because the diameter is 6. And if we look at from the cone's perspective, right, this would be the radius. So we will have to subtract the radius of the hemisphere from this 9 to get this value of height. So h would be nothing but 9 minus 3, which is equal to 6, right? So I think now we have all the values. We have the value of r already for cone. We found the value of h, and for the hemisphere we have the value of r. So let's plug in these values and see what we get. So the total volume would be volume of cone, which is 1 over 3 pi, r is 3, so 3 times 3 is 9, times h, which is 6, right? So this is the volume of the cone, plus this becomes 2 over 3 pi r cube. R is 3, so 3 cube is 27. So this is the volume of the cone, and this is the volume of the hemisphere. Okay, we can cancel some common factors, so we get 18 pi from the first term, and then again 3 times 9 is 27, 9 times 2 is 18, so we get 18 pi from the hemisphere also, and the overall volume is 36 pi. 18 pi plus 18 pi is 36 pi. Just to quickly reiterate, pretty straightforward question. We have a cone, we have a hemisphere, we have to find the total volume. So volume of the cone plus volume of the sphere. A couple of things to keep in mind is that here when we are finding the volume of the cone, this h is the height of the cone itself, not the overall height. So we got to find the value of h, the height of the cone, which comes out to be 6, and the radius is of course the same for the cone as well as for the hemisphere. Question number 3. So we have a rectangular swimming pool, right, whose dimensions are 20 units and 25 units, and which is surrounded by a concrete floor on all the 4 sides, right? And the width of this concrete floor is x in all the 4 directions, right? And the combined area of this bigger rectangle, so to say, is 546. So let's say if this was A, B, C, D, the outer rectangle. So the outer rectangle ABCD has an area of 546, and we have to find the value of x, right, or the width of the concrete floor which is surrounding the swimming pool. So again, pretty straightforward, right? This is 25, this is 20. Each of the concrete floors are x in width, right? So this length AB would be 20 plus x, which is 20 plus 2x, right? So 20 plus 2x, and that times this length, again 25 plus 2x, is equal to 546. So pretty straightforward question. There's no complexity as such here. The length of AB is 20 plus 2x, the length of AD is 25 plus 2x, and we have been given that the area, which is nothing but length times width for a rectangle, is 546. So we get this equation, and we can solve this equation to find the value of x. So let's see. So we expand this, we get 500 plus 40x plus 50x plus 4x square is equal to 546. We can combine these two terms. and write everything in the terms of a standard quadratic equation. So it becomes 4x square plus 90x. You bring 546 to the left side, so it becomes minus 46 is equal to 0, right? You just got to solve this and find the values of x. We can take 2 common to simplify it a little bit, so it becomes 2x square plus 45x minus 23 is equal to 0, right? We can factor it out. It becomes 2x square plus 46x minus x minus 23 is equal to 0. Between these two terms we take 2x common, so we get x plus 23. Between the other two terms we get minus 1 common, we get x plus 23 is equal to 0. And then we get 2x minus 1 times x plus 23 is equal to 0. One value of x is half, the other value of x is minus 23. Obviously x cannot be negative, we will discard this value. Hence the value of x, or the width of the concrete, is half units or 0.5 units. Correct? Again, just to quickly reiterate, with this given information, we know the length of AB would be 20 plus 2x, the length of AD would be 25 plus 2x, the area of the rectangle, which is length times width, is 546, and then we just solve this quadratic to get the two values of x. We discard the negative value and take the positive value. Question number 4. We have a parallelogram ABCD, right? And the area of the parallelogram ABCD is given as 112 square units. And then we drop a perpendicular from this point B to the side AD, which comes at point E. Same thing we do here, in such a way that EBFD is in square. So EBFD is in square, and the area of EBFD is 64. So we know the area of the parallelogram, we know the area of the square as well, right? 112 and 64 respectively, and we have to find the length AE. So a lot of information given here. Obviously the first thing which comes to our mind is that if the area of EBFD, the square, is 64, then each of these sides would be 8, right? So this side would be 8, this side would be 8, this side would be 8, and this side would be 8, right? Because it's in a square. The area of parallelogram is 112. Now, we know that the area of the parallelogram is given by base times height. Base times height, right? So in this case, let's say we don't know the value of this base. Let's say this base is x, correct? So it will be x times height, and the height we already found that it's 8, right? So x times 8, which is equal to 112, as simple as that, correct? Which gives us x as 112 over 8, which is 14 units. So the length of AD, or the base of the parallelogram, is 14 units. We already know the length of ED, hence the length of AE, which is what they're asking, would be 14 minus 8, which is 6. So the length of AE is 6 units. Pretty straightforward, pretty simple question. We know the area of the parallelogram, we know the area of the square, hence we know that each side of the square. We assumed the base of the parallelogram be x or whatever, and we know the height, right? We know the area, so we got the value of the base of the parallelogram. We subtracted 8 from the overall base to get the value of this length AE. Question number 5. We have a rectangle ABCD. The length of AB is 6 units, so this side is 6 units. Obviously this will also be 6 because it's a rectangle. The diagonal's length AC is 10. So AC is 10, and we have to find the length of this CE. Right? We have to find the length of this segment. Okay, so first things first, right? If this is 10 and this side is 6, right? Obviously it's a right angle triangle because it's a rectangle. So we can use the Pythagoras theorem, or we know that, if the hypotenuse is 10, one of the sides is 6 and the other side would be 8. So this side would be 8, right? So we know all the dimensions of the rectangle, correct? And just use the Pythagoras theorem for this right angle triangle. This side is 10, this is 6, hence this is 8. Okay. Now, if we know the sides of the rectangle, we know the area of the rectangle. So area of the rectangle would be 48 square units, right? 6 times 8. Right? And we know that a diagonal of a rectangle divides the rectangle into two equal areas. It means that the area of this half of the rectangle would be half of 48, which will be 24. So the area, total, this is total, and the area of the shaded region would be 24 because half of 48. Now, we know that the area of a triangle is half times base times height. This is a perpendicular here, right? DE is perpendicular to AC because this angle was given as 90 degrees. So we can say that half times the base times height is equal to 24. Correct? This is the base and this serves as the height for this triangle. AC is already 10. So half times 10 times DE is equal to 24, or DE is equal to 24 over 5, right? So the length of this segment DE is 24 over 5, or we can say 4.8 units, correct? So we've got the length of DE, right? And then obviously we have to find CE. Let this be X. We can consider this as another triangle, again a right angle triangle, and we can use Pythagoras theorem again there for this small triangle. Square of this plus the square of this is equal to square of this. We just found that length of D is 4.8. So 4.8 square plus x square is equal to hypotenuse square, which is 6 times 6 is 36. And obviously you solve it, you get 36 minus 4.8 whole square. You can use calculator maybe for this, and you will get 12.96. So x square is 12.96. You take the square root on both sides and you get x is equal to 3.6 units. Again, just to quickly reiterate, right? We knew the diagonal of the rectangle, we knew one of the sides, hence we found the other side of the rectangle. Once we know both the sides of the rectangle, we know the area of the rectangle, and hence we know the half of the area of the rectangle. Once we know the half of the area of the rectangle, which is nothing but this triangle, right? We know the value of the base, we can find the length of the height. Once we know that, then we look into this smaller triangle and use Pythagoras theorem again to find the value of x. Okay, let's take one last question here. We have a circle. There are 2 points on the circle A and C, right? Such that they make an angle of 55 degrees with another point B on the circle, right? And we have to find the measure of arc AC in terms of degrees, right? So one thing which we need to understand is that an arc on a circle can be measured in terms of the length of the arc itself or in terms of degrees as well. And here they are asking us to find the measure of this arc AC in terms of degrees. Okay, but what is the meaning of this arc AC in terms of degrees? It is nothing but the angle which any arc makes at the center of the circle. So let's say that O is the center of the circle. So basically they are asking the measure of this angle, right? Somebody is asking the measure of arc AC, right? It is nothing but the measure of the angle which that arc makes at the center of the circle. Again, pretty straightforward. Now we know, right, that any arc makes the angle at the center, which is twice, this is twice the angle made by the same arc to any other point on the circle. So it directly comes by the property, right? And so angle AOC is nothing but twice of this angle, which is 110 degrees. So pretty straightforward question. The only reason I put this in this set was that I want to make sure that I kind of convey that any arc can be measured in terms of degrees as well, and in terms of length, of course. And in terms of degrees, it is nothing but the angle which that arc makes at the center of the circle. And we know by the property that the angle which any arc makes at the center is twice the angle which it makes to any other point on the circle. So this angle would be twice of 55 degrees, which is 110 degrees. Hey folks, hopefully you liked the video. Keep practicing. In case of any questions, please feel free to reach out to us at info.mathletes@gmail.com. Do like and subscribe. See you in the next session.